Welcome once again to a futures video. The last video ended where I had made the point that a good hedge is when the basis risk is much less than price risk. And it's a very important thing to keep in mind because remember, hedgers are trying to control price risk, and they hedge with futures to do that, but when they use futures, they take on this idea of basis risk. Just to refresh your memory, basis is equal to the cash price minus the futures price, and basis risk is the variance of the basis, as discussed in the last futures video. And so when we talk about basis risk, we talk about this value here changing. And that value is just the cash price relative to the futures price, and specifically the difference. And that difference changes. And understanding how and why that changes is a big part of understanding futures. Okay, so I wanted to finish up with a way of measuring this attractiveness of a hedge, that being when basis risk is much lower than price risk. And there's been developed a way to measure it, and it's called a measure of expected hedging effectiveness, and it's just simply 1 minus the variance of the basis divided by the variance of the price of the spot asset, cash price. So that's a measure of expecting hedging effectiveness. So we expect the numerator to be small and the denominator to be much larger, and therefore it's 1 minus a very small number. So closer to 1 implies better hedge. All right. So next issue is developing a hedging strategy. A decision that a hedger has to make is what kind of futures contracts do I use? Another decision is what contract month should I use? Sometimes some futures contracts have delivery every month sequentially. Okay, so the answer to the what kind of futures to use is often very simple, and the answer is if the asset whose price you're trying to hedge has futures contracts that trade with it as the underlying asset, then of course you'd use that futures contract. If not, you have to do something called cross hedging. Okay, cross hedging means you're using a futures contract to hedge the price risk associated with a different underlying or a different spot asset than the spot asset that underlies the futures contract. For example, historically, airlines, if they were trying to hedge their jet fuel costs, would use heating oil futures, because historically jet fuel futures didn't exist, whereas heating oil futures did. Now you might ask, why did they use heating oil futures? Why not crude oil futures, or why not gasoline futures, or something else? And the reason is heating oil futures seem to be more highly correlated with the changes in the price of jet fuel. Okay, so that's an example of cross-hedging. And with respect to which contract month do I use to hedge, do I use the near month contract or the second month contract or the third month contract? For example, the third month contract has a delivery 3 months from now. The second month contract has a delivery 2 months from now. So in choosing which ones to use, the rule is to use the near month futures contract. And the reason for that is using the near month futures contract reduces basis risk, the variance of the basis, the most. Because of higher correlations between the price of the spot asset and the near month futures contract than exist with the spot asset price changes and more distant month futures contracts. Okay, so the correlation is very important. Remember, the variance of the basis is equal to the variance of the spot asset price, the cash price, plus the variance of the futures price minus 2 times the correlation coefficient times the standard deviation of the cash price times the standard deviation of the futures price, right? And so here we see the correlation again coming in and being very important. So using near month contracts has the highest correlations with the spot price than a second, third, or fourth month contract. Okay, so that's important to realize. And as the correlation of price changes, like you can imagine a table, cash versus futures, okay, and you have a column showing the correlation of price changes, another column showing the variance of the basis. And it's not uncommon to see something like this. Spot month futures, and then second month, third month, maybe sixth month. And you see numbers similar to this with certain assets. The specific asset doesn't matter, but you see things like this. And then, well, you might say, oh, the correlation coefficient isn't changing that much when you go from spot month futures to 6 month futures. But in this one example with heating oil data, here we have the variance of the basis associated with these correlation coefficients. And you can see the difference is quite significant when we look at this. So that's an interesting chart. Well, what do we know about this basis thing? Well, one thing we know is that if we're using a same asset or a same commodity futures contract, we know that on the delivery date, okay, which is not a specific date, but it's the end of it was sometime beyond the last trading day, which is the end of a month and the beginning of the month that has the futures name on it. But on the delivery date, the basis will be 0. Again, this is for a same commodity, just to remind you, for a same commodity futures contract. For a same commodity futures contract. Okay? Well, it's not always the case that that we can match the obligations of our spot asset and our futures contracts. It's not always possible, okay? So if we can match, if we're able to match the cash and futures obligation dates, well, that would be a great way to minimize basis risk, assuming a futures contract existed with a delivery at the point where a cash obligation existed. Cash obligation is a spot asset obligation, the underlying asset. So matching is only available if the duration of the hedger's cash obligations is fixed and known in advance, and there exists a matching futures contract. So the matching strategy, is only possible when, again, the duration of the hedger's spot asset obligations is fixed and known in advance, and there exists a matching futures contract with a settlement that fits the hedger's cash obligations. However, if there's uncertainty about when the hedger will have to perform his cash obligation, then he won't be able to use a matching strategy. Okay, rather, that hedger will have to hedge continuously. Okay, continuous hedging. Okay, and so matching strategies, great if they fit. Otherwise, hedge continuously. We're going to talk how that happens. So it's kind of one or two here to think about. Okay. If you're going to hedge continuously, then you are going to want to use nearby futures contracts and then just roll the hedge forward. Okay, because you have less basis risk when that's done. Most hedgers use a near month or a second month contract, and near month would be best. Okay, so we have some examples coming up with this in a bit. But if you can't match, you have to hedge continuously. Then you will see that you roll your hedges forward. We have some examples coming up. Okay, let's think for a second about the optimal futures position to assume. Okay, the optimal futures position to assume. Okay, well, so you can think about this as we have a portfolio that consists of the spot asset and a position in futures. Okay, and it's just kind of common sense that the change in the value of that portfolio is equal to the change in the cash price times the size of the cash position minus the change in the futures price times the size of the futures position. Okay? And we can set, I guess ideally that change in the value would be 0. Okay? So we set 0 equal to this, and then we do some algebra. I'll spare you the algebra. And we end up with the following, that Q sub F, which is the size of the futures position, and I put a little star there to indicate I'm talking about now an optimal condition, would be equal to the size of the cash position times delta CP over delta FP. Change in the cash price divided by change in the futures price. This term here, circled in red, is known as the hedge ratio. That is the hedge ratio. Okay. All right. So, the optimal size of the futures position then would be, well, Q sub FC. This stands for the standardized size of the futures contract. Back with our wheat futures example, the standardized size of that contract is 5,000 bushels. So the optimal size of my futures position here would be the standardized size of the futures contract, Q sub FC, times the optimal number of futures contracts. So NFC star is the optimal number of futures contracts. And that is equal to the right-hand side in the equation above. Okay, so put it like this. Now, when we solve this, algebraically manipulate this, for NFC, we, of course, NFC star, we get that it's equal to Q sub C divided by Q sub FC. That's the standardized size of the futures contract right there, again, multiplied by that hedge ratio. And I'm going to indicate that that hedge ratio then is something that we'll refer to as the optimal hedge ratio. Okay. Well, let me back off that. That would be the minimum variance hedge ratio, which may not, and I'll say probably is not, the optimal hedge ratio. Okay, so there we have this. Again, the optimal number of futures contracts to take a position in is equal to the size of our cash position divided by the standardized size of the futures contract times the optimal hedge ratio. Let's think back to our wheat example from a few videos ago. The size of our cash position, it was our expected harvest, technically not a spot asset yet because wheat seed is quite different than harvested wheat because of the possibility of drought and flooding, etc. So, but our expected harvest there was 100,000 bushels, okay, and the standardized size of the futures contract was 5,000 bushels, okay, and this 100,000 divided by that is 20, and we remember that we did take a position of in 20 futures contracts, our farmer did, and so the implication is there that the hedge ratio must have been 1. And that's correct. And assuming the hedge ratio is 1, as we did earlier, is the naive method. Okay? Okay? Just assume the hedge ratio is 1. In the prior example, it may have worked, and it may not have. It depends upon the size of the harvest. And, okay? Another way of estimating this hedge ratio. Okay, another way of estimating. Remember, the hedge ratio again is this. Don't forget, it's delta CP, delta FP. Another way of estimating that is to use simple regression and use an equation like this. The y variable, the dependent variable, will be the change in the cash price, and that would be equal to the vertical intercept beta naught plus the slope coefficient beta 1 times the change in the futures price. Okay? And it ends up that this regression output right here could be a good approximation for the optimal hedge ratio. Okay? This beta 1 estimate, which gets spit out by the regression software, would be a good candidate to being the optimal hedge ratio. There's some issues that we'd have to be concerned with. Before I go into them, let me just remind you that beta 1 would then be the change in the cash price associated with a given change in the futures price. Okay, that is beta 1, and that beta 1, of course, is, just so we're super clear, is that right there. Again. Alrighty. Now, but when we're doing this, we have some issues. This change in cash price term, this change in futures price term, of course, they're simultaneous observations. Okay, no doubt about that. But, we have to wonder how frequently do we measure change in cash price and change in futures price? Do we measure them every minute or every hour or every once a day, once a week, once a month? What's the frequency? And the answer to that's going to affect our beta output. But there's more. A second issue is for what period of time, for what length of time. Put question marks on these. For what length of time do we measure simultaneous observations of the change in the cash price and the change in the futures price? Do we do it for, let's just say we choose daily changes? Do we do it for a month or 6 months or a year or 5 years? What do we use? A third issue is once we decide on a length of time, let's say we decide to do daily price changes for 5 years. Well, then the third question is which 5-year period? In the most recent 5? Do we skip a year and do the 5 that preceded that? What do we use? So these are 3 questions we have to consider whenever we're planning on using regression analysis with this equation to generate a beta estimate as a proxy or a best guess for the hedge ratio that we should use. So these are some of the issues we have to consider when we're choosing how to set up our analysis. All right. And that's enough for this video. Thanks for watching.